All right, hello, and today we're going to start with section 4.8. We've been defining polynomials with our polynomial terms, mono, bi, and tri, and then over four or more as polynomials. We've been adding, subtracting, multiplying, and of course today we're going to divide polynomials. Division of polynomials is similar to what is done in our simple arithmetic. So here we have a monomial divided by a monomial. And we can break this apart. And we know 2 goes into 10 5 times. And we remember our rules for exponents. We have like bases in the numerator, the denominator. Subtract the denominator's exponent from the numerator's exponent. So we have 5 times x to the first. That's quite mechanical. Our rules for exponents, you should maybe be able to do mental math with this one. Okay, dividing, we have x to the 9th over 3x squared. Dividing polynomials, it happens to be a monomial divided by a monomial again. We can break that apart. That's 1/3 times x to the 9th over x squared. So that's 1/3 times x. We're going to subtract the denominator's exponent from the numerator's exponent. We get 1/3 x to the 7th. Or you could write that as x to the 7th over 3. Kind of as they presented it to us. Negative 18x to the 10th divided by 3x cubed. Well, again, it's all multiplication, so we can break this apart and get our constants together. X to the 10th over x cubed. 3 goes into negative 18 how many times? 3 times what is negative 18? Negative 6. X to the 7th. We're dividing polynomials. 9x to the 8th plus 12x to the 6th divided by 3x squared. We can rewrite that as 9x to the 8th plus 12x to the 6th, all divided by 3x squared. We can break this down. It's the first term, 9x to the 8th divided by 3x squared, plus the second term, 12x to the 6th divided by 3x squared. 9 goes in, or 3 goes into 9 how many times? And we have x to the, subtract the denominator's exponent from the numerator's exponent. 3 goes into 12 how many times? Like bases in the numerator and denominator, subtract the denominator's exponent from the numerator's exponent, and we get dividing polynomials. X squared plus 5x plus 6 divided by x plus 2. The first few that we looked at were a polynomial divided by a polynomial as a monomial divided by a monomial. We had a trinomial divided by a monomial. Now we're looking at a trinomial divided by a binomial. So longhand division look like that. Here's our dividend. This is what we're dividing by, the divisor. And our answer is called the, when we divide, our answer is called the quotient. Kind of an odd term. Okay. So we're looking to solve for the quotient. So first, check your dividend. Just scan it. Are there any missing terms? Remember, we have to have placeholders. So this is 1001, which is different than 1. So the placeholders have to be significant. We have x squared, x to the first, and x to the 0 power. So all placeholders are represented in our dividend. So we scan that, we can go ahead. X goes into x squared how many times? X times what would be x squared? X times x. Okay, and then we need x times x is x squared, but x times 2 is 2x. Let me just move over here to the side a second. 3 goes into 15. Longhand division, 3 goes into 15, how many times? 5. 5 times 3 is 15. We draw our line and subtract, and we get 0 for our remainder. Okay, mechanics are the same. So x times x is x squared, and x times positive 2 is 2x. We're going to draw our line and subtract the polynomial. So make sure you're managing, we're subtracting a polynomial now, not just a single term. Mechanics are the same, but we're subtracting the polynomial. Okay, so this is asking for the opposite, right? So I have my polynomial, and the opposite of each term, that goes to 0. 5x plus a negative 3x is 5x, subtract 2x is 3x. Maybe it's easier if we change subtraction to addition and add the opposite of this polynomial, which is the opposite of each term. So x squared plus its opposite goes to 0. 5x subtract 2x is 3x. And then we bring down the next term. And x squared goes into 3x how many times? X times what would give you 3x? 3. 3 times x is 3x. 3 times positive 2 is 6. Then what do? We draw our line and subtract the polynomial. Subtract every term. Change subtraction to addition and add the opposite of this polynomial. So I have 3x, its opposite, plus 3x would go to 0. 6 plus 6's opposite would go to 0, so I have a 0 remainder. I know there'll be a couple of these on your homework and tests as you move forward in your math career. Okay, so how would we check this? Well, how do we check this? How do you check to see if that's correct? 3 goes into 15 5 times. You take your divisor times your answer, your quotient. 3 times 5 is 15, and it should check your dividend. So we're going to do the same thing. Our divisor times our answer. And I have polynomial, binomial times a binomial. So I'm going to get out my blue cards. Back to these special product rules. Are the first 2 terms the same? Yes. Are the last 2 terms the same? No. So I need to use FOIL, the square of a sum, the square of a difference, or the product of a sum and a difference. Remember, with the square of the sum, the first 2 terms have to be the same and the last 2 terms have to be the same. The square of a difference, the first 2 terms have to be the same and the last 2 terms have to be the same. And for the product of a sum and a difference, the first 2 terms have to be the same and the last 2 terms have to be the same. So all that's left is FOIL. So we're going to use FOIL. The first terms will be x squared. The outer terms are going to be 3x. The inner terms will be 2x. And our last terms, 2 times 3 is 6. Remember, with FOIL, we expect to collect like middle terms, and we get a positive 5x plus 6. And this should match what? As we're trying to check, this should match our dividend. So you can circle your answer. X squared plus 5x plus 6 divided by x plus 2. So we have a trinomial divided by a binomial. Let's look at this. 3 goes into 26. 3 goes into 26. How many times? 3 goes into 26, how many times? 8. 8 times 3 is 24. 8 times 3 is 24. Draw your line and subtract. We get 2. It's less than the divisor, so we have a remainder of 2. How do we check that? Well, it's your divisor, 3 times your answer, plus any remainder. 3 times 8 is 24, plus we had a little bit left over, and we get 26. This needs to match what? Your dividend. Okay. Those are mechanics you know and have done before, I'm sure. All right, so here our divisor is x plus 2. We're going to divide it into x squared plus 5x plus 6. So again, divisor, dividend, and quotient is your answer when we divide. Just scan to make sure all placeholders are represented, that we don't have any missing terms. X squared, x to the first, x to the 0. So we're good. X goes into x squared how many times? X times what will give you x squared? X. X times x would be x squared. X times a positive 2 is going to be a 2x. Draw your line. We're going to subtract the polynomial. Subtracting, we change subtraction to addition, and we take the opposite of the entire polynomial. So that goes to 0, and 5x minus 2x would be a positive 3x plus 6. Did I just do this one? Okay. I think you know how to do that one already then. I gotta look down one. X squared plus 2x minus 12 divided by x minus 3. Okay, so our divisor is x minus 3 goes into x squared plus 2x minus 12. Again, scan. Are all your placeholders represented? Here's to the second, to the first, to the 0 power. That's good. Change subtraction to addition and add the opposite so you know the sign of the term. X goes into x squared how many times? X. X times x is x squared. X times a negative 3 is going to be a negative 3x. Draw your line and subtract the whole polynomial. We're going to change subtraction to addition and add the opposite. Change subtraction to addition and add the opposite. The opposite of x squared is negative x squared plus positive x squared goes to 0. We have a negative 3x. Its opposite is? We have a negative 3x. We need its opposite. It's positive, so we get 5x. Bring down the next term. X goes into 5x how many times? X times what would give you 5x? 3. I think it's 5. Yep. That's okay. I make mistakes too. So 5 times x is 5x. Yep, that's good. And 5 times a negative 3 is a negative 15. Draw your line. Subtract this polynomial. Change the sign to addition and add the opposite of that polynomial. You may want to take care of this. Change subtraction to addition and add the opposite. So we have control of the signs. I have a positive. I need its opposite. That goes to 0. This is negative 15, but I need its opposite. For positive 15 plus a negative 12 would be a positive 3. 3 is actually x to the 0 power. So it's a placeholder less than our divisor. So this is our remainder, 3. So now how are we going to check? My divisor, x minus 3 times my quotient, x plus 5, plus a little bit. This is FOIL. The first 2 terms are the same, but the last 2 are different, so we'll have to use FOIL. That's x squared plus a 5x. Inner terms, negative 3x. My last terms are negative 15, but I got a little bit left over there, plus 3. We expect we can collect like terms when we use FOIL. Looks like positive 2x. 15 is negative plus 3 would be negative 15 plus 3 would be negative 12. And that needs to match our dividend, which is x squared plus 2x minus 12. So you can circle your answer. Division of polynomials. Okay, this is our divisor. X plus 1 goes into x cubed, but now you want to be careful. This time we are dealing with missing terms. And just remember that a 1001 is much different than 1. Zeros have placeholder significance. Well, so does our 0x squared. We have to count down by degree. There's a 0x to the first power represented, but we do have a constant. That's 1 times x to the 0 power. So 3, 2, 1, and then x to the 0 power. Very important. It makes sense, right? It's just one of those things we forget about when we're doing our homework and testing. We get in a hurry. So put that on your radar. Missing terms, we do have to take control, be in charge of that. So x goes into x cubed how many times? X times what is x cubed? X times what is x cubed? X squared. X squared times x would be x cubed. So we got that. And x squared times 1 is plus x squared. What do we do next? Draw our line, subtract the entire polynomial. Subtracting polynomials, we change subtraction to addition and add the opposite of the polynomial. That means the opposite of each term. So I have x cubed, I need its opposite, plus x cubed goes to 0. I have a positive x squared, but I need its opposite, plus 0 would be a negative x squared. And then bring down the next term. Remember longhand division. Just do a longhand division problem, sketch it out over on that side. That's kind of your cheat sheet. So I have x times what would give me a negative x squared? X times what gives me a negative x squared? A negative x. A negative x times x would be a negative x squared. A negative x times 1 would be negative x. Negative x times 1 is a negative x. Draw your line, and we subtract the entire polynomial. Remember subtraction of polynomials? Change subtraction to addition and add the opposite of this polynomial, which changes the sign of each term. So I have a negative x squared. I need its opposite. That's positive x squared, plus a negative x squared goes to 0. This is a negative x. I need its opposite. The opposite of a negative x is positive x. And I need to bring down the next term. X goes into x how many times? 1. Positive 1 times x is positive x. 1 times 1 is 1. Draw your line, subtract the entire polynomial. When we subtract polynomials, we change subtraction to addition and add the opposite of the polynomial, which changes the sign of each term. I have a positive x, I need its opposite, plus x goes to 0. I have a positive 1, plus its opposite is a negative 1 plus 1 goes to 0. So I have a 0 remainder. X squared plus 7x plus 10 divided by x plus 3. So I have a polynomial. It happens to be a trinomial divided by a binomial. My divisor is x plus 3. It goes into x squared plus 7x plus 10. X squared is represented, x to the first degree, and x to the 0 power. No missing terms. X times what will give you x squared? X times x is x squared. X times 3 is 3x. Draw your line, subtract the entire polynomial, subtraction of polynomials. We change subtraction to addition and add the opposite. I have an x squared, I need its opposite, plus x squared goes to 0. I have 3x squared, I need its opposite. Negative 3x plus 7x would be a positive 4x. Bring down the next term. X times what is 4x? 4 times x would be 4x. 4 times 3 is 12. Draw your line and we subtract the entire polynomial. Subtraction of polynomials, we change subtraction to addition and add the opposite. That is, it changes the sign of each term. I have 4x, I need its opposite. Negative 4x plus 4x goes to 0. I have positive 12, but I need its opposite. Would be negative 12 plus 10 is negative 2. This is 2x to the 0 power. It's less than the degree of my divisor, so I have a remainder of 2. To check this, it's your divisor times your quotient plus your remainder, your little bit left over. Couple of application problems that relate to what we've been working on. The number of patients with the flu who were treated at Riverview Clinic increased from 25 one week to 60 the next week. What was the percentage of increase? The number of patients who were treated the first week was 25. Plus I had an increase, which equals 60. All this was a percentage of increase of what my known was, 25. So 25 plus a given percentage of increase is equal to 60. Let's see, this is multiplication. So I can subtract 25 from both sides. P times 25 equals 35. I'm trying to solve for that percent of increase. This is multiplication, so I'm going to divide both sides by 25. $35 divided by 25 is 1.4. But we are to convert our final answer to percent. What was the percent of increase? So P in percentage, not decimal format. 1.4 is in decimal format. 1.4 is equal to what as a percent? We move our decimal place 2 places to the right and add the correct labeling. So 140% is the same as 1.4 in decimal format. So our increase was 140% from the first week to the second week. Todd's quiz grades are 82, 88, 93, and 92. Determine in terms of an inequality. Inequalities, remember, greater than or less than, greater than or equal to. What scores on the last quiz will allow him to get an average quiz grade of at least 90? Well, we know the grades so far. So he has 82 plus 88 plus 93 plus 92, and he's going to get one more quiz grade, but we don't know what that is yet. So one more quiz score is unknown, but we know that we want it to be a grade of at least 90%. So at least 90%, that could be greater than 90, right? At least 90% is equal to. When we do a calculation for average, we take the number of data items and divide by the count, right? So how many data items do we have? 5. So we're going to divide by 5. So let's see, I can add 82 plus 88 plus 93 plus 92 and get 355. So does that make sense to you? He's got his 4 grades. He's looking for one more, but wants to maintain an average score of 90 or better. So he's going to have 5 test scores, 1, 2, 3, 4, 5. Find the average of 5 test scores. If we multiply both sides by 5, 5 times 90 is 450. Now I can subtract 355 from both sides. I'm using my multiplication and addition principles to solve equations. X is greater than or equal to 450 minus 355 is 95. So Todd's last test score must be at least 95 or greater to maintain his overall average of 90.
What page number?
Yep.
What page number is it?
Oh, I'm sorry. These are at the end of this section, page 330. And there's these all 3 that we're working on, plus the next couple, page 330. Usually at the end of this section, they'll have story problems associated with what we're working on in that section or previous. Not always, so that's why I try to catch them when they do present. Okay, this is 53 on page 330. Okay. The perimeter of a rectangle is 640 feet. The length is 15 feet more than the width. Find the area of the rectangle. So we've already discussed we should jot down, sketch, draw. Let's draw a rectangle. It says the length is 15 more than the width. So if the width is W, the length is equal to the length is means your equal sign. Length is 15 feet more than the width. So if the width is W, the length is W plus 15. And we're told that the perimeter is equal to 640 feet. do we solve perimeter? Perimeter is the distance all the way around. Like if we want to walk around the garden, or if you want to put a fence around the backyard so the rabbits don't get in. The perimeter is the distance all the way around, right? Just recall, I guess, remember that. So 640 feet, our distance, is the distance all the way around. So we're going to have 2W, there's a W here and a W here, 2 times the width plus 2 times the length, right? And our length in terms of W is W plus 15. And I should maybe put perimeter is equal to 2 times the width plus 2 times the length. That's what you'd look up or find in your research to find the formula if you didn't remember. Okay, first we have distribution. 2W plus 2 times W would be 2W. Pick up your sign. Plus 2 times 15 is 30. Collect like terms. That'd be 4W plus 30 equals 640. Use your addition principle for solving equations and subtract 30 from both sides. As we're trying to isolate W, is that 610? I'm trying to solve for W, so I'm going to multiply by the reciprocal of the coefficient on W. That's a multiplication principle for solving equations. 4 times its reciprocal goes to 1 by our definition. 1 times W is W equals. I'm getting close to solving for W. But if I multiply this side by 1/4 because of my strategy, I have to multiply the other side by 1/4. Remember, reciprocals by definition includes maintaining sign. So 4 goes into 610 how many times? 152.5. So our width is 152.5 feet. Our length then is W plus 15. So 152 plus 15 is 167.5. Are we ready to circle answers? The perimeter of a rectangle is 640 feet. The length is 15 more than the width. Find the area of this rectangle. So this is step 1. We have to find the area now of this rectangle. Area of a rectangle is equal to they're not giving you the formula, so you're supposed to remember length times the width, and we know the length and the width. The area is equal to the length is 167.5 times the width is 152.5. $167.5 times 152.5 is 25,543.75. And how do I label it? This is feet times feet for feet squared. 4 square feet. Okay, questions on that one? Probably probably see something like that, more so as you continue in your math career, because it's a multi-step story problem. It involves more than one step. And here's a favorite returning in your math career. Book pages, locker numbers, apartment numbers. This is book pages. The sum of the page numbers on the facing pages of a book is 457. Find the page numbers. The sum of the page numbers on facing pages of your book. Well, open your ebook. I'm going to open my book. These are facing pages, right? They face each other. As I lay the book open, one page number is 324. The facing page number is going to be 325. Okay. I'm going to open my book again. And facing pages, this one is 768. So its facing page number is 769. Okay. So I have facing page numbers. If one page is X, well, let's see. If one page is 15, the next facing page number is 16. We're counting by one, right? We're just looking at the next one. So if my page is X, the next facing page number is X plus 1. If my page number, this is facing pages now. So when you open your book, you lay them open. If the first page is 330, the next facing page is 331. So if this is X plus 1. Right? Yes? Makes sense. We just have to think about it a little bit. Work with your model a little bit more. If we have 769, open our book and we have page 769. The next
77.
Oh, it is 770. That's a good number. And sure enough, if this is X, 769 plus one more is 770. So we got our model. So X plus 1 is supposed to equal 457. So our first page number plus its next facing page number equals 457 when we add the facing page numbers. Let's see, collect like terms, that's 2x plus 1. 2x equals 456, subtracting 1 from both sides. I'm solving for x, not 2x. I'm going to divide both sides by x by 2. 456 divided by 2 is 228. So then x plus 1 would be 229. Check 228 plus 229 is equal to 457. So your facing page numbers are 228 and 229. Okay, at my math lab. Pretest, original retake, and homework are done.
Yeah.
Chapter 4, you're working on your homework. It's due on the 12th at noon. Due on the 12th at noon. And your chapter 4 original retake tests due as you need. The original is taken by everyone. Retakes are optional. If you receive less than 85% on the original, you're a candidate to take the retake and bring your score up to a maximum of 85%. It's on your syllabus. The mastery exam. The mastery exam, 200 points. Take once. One attempt. Is due on the 18th, 11/18 at noon. The 18th, here's today, the 7th. That's all of next week up till Monday, the 18th. It is proctored. Your midterm mastery exam is proctored. Which means you have to have someone in authority watch you as you take the exam. I have mailed this form, emailed it to you, so you should all print, you'll have to print it out, complete it at the time of your testing, and then fax it or email it back to me. The directions. It is open now. Your exam will close on Monday the 18th. This is an online MyMathLab exam. You have 2 hours to complete the exam, but you need to complete it in one setting. It's not start and stop and start again. The exam will be comprehensive. Comprehensive means it covers everything that we've covered since day one. In particular, it covers topics from our pre-test just in time. Chapter 4, Chapter 5, Sections 5.1 and 5.2. The exam is open books, open computers. You are not allowed to work with anyone else on the exam. You must arrange for a person in authority or a public place to proctor your exam by filling out the form below. So filling out the form below, you fill in your name, your email address, your proctor's name, your proctor's email address, your proctor's relationship. How did you choose this person? This person can be a teacher, a counselor, a librarian, a supervisor, a boss, clergy. Our Minnesota West Larks provide proctoring services, but you need to make an appointment. If you're choosing some proctor as an authority in the community, make sure you give them lead time to make your appointment.
So it could be any teacher?
Any teacher, yep, any coach, any supervisor. The start date and time needs to be entered by your proctor. They need to sign off. And the end day and the end time needs to be filled in and signed by your proctor. If this is not completed or not turned in to me, it's a 0. You should have seen this form or very similar to it before. So proctoring should not be new to you. It is a requirement within the math department. Okay, so arrange ahead of time or make your appointment. Good examples are teachers, counselors, coaches, librarians, supervisors, bosses, clergy. Make certain in advance that your device is compatible with MyMathLab. Once you start the exam, it will grade 0. There's not a second attempt. So make sure that your device is compatible. Minnesota West Lark computers are compatible with MyMathLab. No exam score will be recorded unless this exam is completed correctly, scanned or emailed or faxed to my attention, and that information to mail it or to fax it or to scan it to my email address. This has been emailed to you, very valuable piece of your midterm exam. This has to be signed, completely filled out, and returned to my attention to get your grade. Okay, questions? All right, have a great weekend.